Hi there, and welcome to this practice set. This is complex numbers part 2 with focus on operations. If you are looking for complex numbers part 1 practice set, please, I'll put a link up here for that. Make sure I click on the right thing. Part 1 practice set. Okay, if you're looking for the part 1 practice set, click up there. We'll link you over to that because you don't want to be doing practice problems on a lesson you have not had. That never ends well. Please like and subscribe for more math content. Drop a question below or give me some feedback, and check out the other videos that we have on the channel. As always, pause the video to work these problems on your own and then come back to check your work. All right, now, usually I click on over to the next slide, but I didn't this time. I did put here perform the indicated operation, which was a change from what I originally wrote when I wrote the practice set. And that is because I want you to really pay attention to what the operation is. So before you proceed to check your work on the following videos, I want you to double check that you paid attention to the operator. The first one is adding. The second one is multiplying. The third one is subtracting. The fourth one is subtracting. The fifth one is multiplying. The sixth one is adding. And the seventh one is multiplying. And the eighth one is dividing. If you are now realizing that you multiplied for all of them, pause the video again and go back and rework those problems. You will be an expert at multiplying, but also you want to get them right. So double check that before you go on to the following slides. Okay, so for these first ones, I'm going to show you how I would do them. At least for this adding one. So for the adding one, I would not show any work, and I typically do not require my students to show work for the adding. And that is because you can simply combine like terms. So this would be -3 plus 6 and -2i minus 4i, or if it helps, -2i plus -4i. And so if you are capable of doing that in your head, -3 plus 6 is 3, and -2i minus 4i is -6i, or you might just write it as 3 minus 6i. If you need to do more work than that, your work would probably look like this, where you remove the parentheses in a separate step and then somehow visually group those like terms together. Okay, and then go from there. -3 plus 6 and -2i plus -4i is -6i. You do not need to do that, but if it helps. Second one is multiplication. And what I would probably do, and you always want to listen to your teacher's direction, is I'm going to show my work. So I am going to show it in the body of the problem here. So this is -3 minus 2i times 6 minus 4i. 6 times -3 is -18. This will be -12i. This will be positive 12i. Interesting. Oh, I see why. That's interesting. I just wrote these problems. I actually did not work these in advance, but this is kind of cool one. -2i times -4i is positive 8i squared. And ooh, look at that. That is unintentional, but kind of cool. So what are we left with? Those cancel out. So 12i minus 12i is gone. So -18 plus 8. And then I'm going to do my substitution right there. That's going to be a -1, which means it's -18 plus -8, or -26. And you might be saying, how did we get a real number? I thought it was only if there were conjugates that we got real numbers. That's super weird, huh? Here's what it is. If you look at the 6 minus 4i, okay, I see a common factor of 2 right there. Okay, I see a common because 6 and 4 are both even. And I also, because I know what I'm looking for now, instead of factoring out a 2 to get that, okay, I am going to factor out a -2. So if I factor out a -2, so we're going to pull a -2 out. You think, well, -2 times what would give me +6? So that would be -3. -2 times -3 would give you +6. And then -2 times what would give me -4i? Well, that would be +2i. And then remember the other thing we were multiplying by? And now you can see that they are conjugates. So we have -3 plus 2i and -3 minus 2i, and that is why those end up canceling out. And we just have this other factor of -2 there. So essentially, like, that product is like double what it would have been if we hadn't had the factor of -2 in there. So yeah, that was not intentional on my part. Probably threw you for a loop. I'm sorry. Threw you for a loop. But if you got -26, like, bravo, yay. Nice job. Okay. All right, next one. This is a subtraction problem right here. And so when I go to remove the parentheses, I do want to make sure that I subtract everything. So this will be minus -3. So you got a negative right there, and then you got another negative right there. If you subtract a negative, that is the same as adding the opposite, and the opposite of a negative is a positive. And then you are also going to subtract that 8i. 2 plus 3 is 5, and -4i minus 8i is -12i. Another subtraction one, okay? So be careful that subtraction goes with all the things. So -3 minus 2i, and this will be -6, and then minus -4i. If you subtract a negative, that is the same as adding. Combining our like terms, we have -3 minus 6, so that is going to give me -9. And -2i plus 4i, which will be +2i. There we go. Okay, if you've made some mistakes there, just grab a different color pencil, grab a pen. Do not erase your work, okay? That is such a huge pet peeve. Your teacher, if you're making mistakes, your teacher needs to see what kind of mistakes you're making. If you're doing this on your own, who cares? You're doing it for personal enrichment, and go you. All right. Next one is multiplication. So again, I'm going to set up the body of my work here. And we'll have 2 minus 4i, and then -3 plus 8i. -3 times 2 is -6. This will be +12i. This will be +16i, and then -32i squared. If you're starting to get comfortable with that, instead of writing the i squared, you might just write -32 times -1. Okay, that would maybe be the next step in kind of collapsing how much work you're doing. And then the step after that would be, instead of writing -32, you just write a +32. You flip the sign. Again, don't rush any of that. Okay, do not rush that process. So this would be -6 plus 28i minus 32. And here's where I'll do that substitution. -32 times -1. So this would be a negative times a negative, which is positive. And then we want 32 minus 6, which is 26. So what is it? -6 plus 32 is +26. Yeah. All right. Ta-da. And now we have another +1. So again, you can do this without removing the parentheses. So you have 2 plus -3, which is -1, and -4i plus 8i, which is 4i. If you are more comfortable removing those parentheses so you can see them better, that is 100% up to you. Okay, you do not have to do it, but it might be nice. All right, last one for the multiplication here. This one is a conjugates problem, okay? And so we're expecting the middle piece to drop out. If you feel comfortable doing this another way to make it faster, you can. 4 times 4 is 16. So one of the things you might do to make it faster is say, hey, I know these are conjugates. Those are going to cancel out. I'm not even going to do them. Okay. I'm not even going to bother doing them because I know they're going to cancel out. And this would be negative 25i squared. So we have 16 minus 25 times negative 1. So that is positive 25. And what is that? That is 41. If you do fill in those other pieces, you would have 20i and negative 20i. But again, this is the value of doing practice out. That practice does help you, just find these like ways, like I know how this is going to work out and I can do it faster. All right, now for the division, oh, so much fun with our division. Division, if you're hating it, is not very common. So what we're going to do is multiply by the number 1. Okay, our goal is to get that out of the denominator. We need to rewrite this. The way we're going to multiply by 1 is we are going to multiply by something over itself, and that something is going to be the conjugate of the denominator. The denominator is the piece that's the problem there. So now we probably need some space for some scratch work. So I'll tuck that over here. We've got 2 plus 3i times 3 plus 4i. This is my numerator. So this will be 6, 9i, 8i, and 12i squared. 9i plus 8i is 17i. And over here, I'm going to do plus 12. And then instead of the I squared, I'm going to say negative 1. Okay. In my denominator, it should be nicer. We have 3 minus 4i and 3 plus 4i. So we have a 9, and then those guys are canceling out because they're conjugates. And we have minus 16i squared. If you are interested or just did it out, this would be minus 12i and plus 12i. So my denominator then is 9 minus 16. And then again, with that I squared, I'm going to go ahead and substitute in that negative 1. And then we have just a little bit more scratch work to do. So 12 times negative 1 is minus 12. Drop the I there. And here, this would be negative 16 times negative 1, which would give you a positive 16. In the numerator, 6 minus 12 is negative 6. And in my denominator, 9 plus 16 is 25. You might leave it like that. I don't know why I want to drop the I off my 17 there. I just did not want to hang out. You might write it like this if you are required to do that A plus BI form. Okay. So, yeah. Okay. Not an awful amount of time. Just for reference, if you're timing, I've been on this slide for about 3 minutes, 50 seconds to do both problems, including all the scratch work and the explanation. So it might take you longer than that. I've done these for a super long time and can go through them pretty quickly, but it should not be taking you like 10 minutes to do one of these problems. So it might take you 2 or 3 minutes to do number 7, and then 4 or 5 minutes maybe to do number 8, depending on how quickly you can move. All right. So number 9, so solve that equation and then solve number 9 by graphing and verify that there are no x-intercepts. So this is one that we have to do with the quadratic formula. So A is equal to 1, B is equal to 1, and C is equal to 2. The quadratic formula is this: the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. And we're going to dump in those values. So the opposite of 1 is negative 1. Then we have 1 squared minus 4 times 1 times 2 all over 2 times 1. And what do we have in here? We have 1 minus, because 1 squared is 1. 4 times 1 times 2 is 8 over 2 times 1. Negative 1. 1 minus 8 is negative 7. And here you might be like, I don't know what I'm supposed to do. Like, what form should that look like? So if you got it there, like, awesome. Okay. Here's what you would do. You would look at that and you would say that is the square root of 7 times negative 1, which is the square root of 7 times the square root of negative 1, which is the square root of 7 times I, and you would probably write it as I root 7. You just kind of switch the order. And so the final form for that answer would be negative 1 plus or minus I root 7 over 2. So that's just a little bit of like, what would you do? Okay, with a little bit of practice, you would be able to do that in your head, but probably not at the get-go. Okay, and you could do a couple more things with that. You could split up the fractions, like what form it should be. You know, it's going to vary a little bit. Now, number 10 said solve number 9 by graphing. So to solve that by graphing, what you do is you take this 0 and you substitute that with a y, and then you look for the x-intercepts. Why do we look for the x-intercepts? Because every point on that x-axis has a y-coordinate of 0, which is what that little substitution trick there is. So let's take a look at that graph. Okay, and you can see here, there's the graph. So y equals x squared plus x plus 2. You could also put the y equals on the other side. And there is the graph, and there's my x-axis. And so we are verifying that there are no x-intercepts. And we know that because when we got the solutions were complex. Now, this comes in very handy in when in your study of higher order polynomials. So typically, if you're doing this lesson and you're in an algebra 2 class, that's kind of where we go next, is we go into things that go past an exponent of 2 and launch into higher order things with an exponent of 3 or 4 or 5. It's not as bad as it sounds, but we keep in mind that we might have these complex number answers. Okay, that's it. So like and subscribe for more math help. Ask a question or drop a comment below and explore the channel to see what else we can help with. I am actually very excited and passionate about helping students understand math. So scrounge around the channel, and if you can't find what you're looking for, send me a message and I will help you out as best I can. Hope to see you in a future video.